Okay. Okay, so we got this earthquake equation, M equals 2/3 log of S over S naught. And we have our, I'm gonna write it small, but our translation between logarithmic and exponential form. Because we're going to solve this for S. S is stuck inside that log, right? So what do we have to do? We have to use the fact that log of the base b of a equals c is equivalent to b to the c equals a. So if our variable is stuck inside of this, now it's accessible to us just for, you know, standard, regular old algebra 2. Okay. So to solve this for S, we've got to translate it. Okay. So go ahead and work out your translation. We'll see how you do on that, and then we'll go from there. So we're a little bit stuck at this point. You have to put this into form like this, because your S is inside your log. You're going to have to get this A thing outside of the log. So how do you put it into this form? Why isn't it in this form? Okay. So then what do you do to both sides of the equation to put it into that form? Okay, now the first impulse was subtract 2/3 from both sides, but you can't undo this multiplication because it's 2/3 times a log by subtracting 2/3. Okay, you divide by 2/3, which was exactly what we said, what you said when I raised that objection. Okay, and then you got and you want to write out the steps. Because if you don't write out the steps, you're not reinforcing the idea. Okay. Then you got 2/3 divided by 2/3, and that's 1. So you get this on this side, you get the log. Over here, you're dividing by 2/3, so you multiply by the reciprocal. Now, I would say that you could have done this step by multiplying both sides by 3/2. 3/2 of 2/3 is 1, and you get a 2 3/2 over here, right? But if you want to think division by the fraction, it's a little more complicated because you got to worry about a little bit more stuff. So if you got a fraction here that you want to get rid of, you multiply by the reciprocal. It's a little easier than dividing by the fraction. Okay, kind of maybe want to lock that idea away. But either way, it works as long as you remember that the division here is multiplication by the reciprocal. So we'll write it out this way. Okay, and just a little note. This is okay, but it's really a little more elegant and a little less error prone to multiply by 3/2. So kind of locked out of way. Okay, so now we've got this. And now we do seem to have it in a form where we can translate it, right? Because now we have nothing in front of a log of something. And that something contains a variable we're trying to solve for, so we can do the translation. So see what happens next. Okay, now we got the answer 1 equals I forget how you wrote it out. Anyhow, okay, the problem was log log. What's the base? Can you show me with your fingers? Well, I'm going to assume you don't know because apparently you wanted to use a 1 for the base. Okay, that's never a good idea because 1 raised to any power is still 1. Okay, log log means log to the base 10. Okay, so log of A is the base 10 log. Natural log of A means log to the base E. So to be explicit here, you would want to write this as log to the base 10 and then translate it. Identify your A and your C and your B and write it accordingly, which I'm confident you're going to do correctly. Okay, so we translate this, and once we get it to this stage, by the translation, you get 10 raised to the 2/3 m power equals S over S naught. Now the question is, what do we have to do to both sides in order to isolate S? Okay, so let's raise it that way. You wanted to write out, you just want to move this S0 over here. Okay, that's not what we do. We multiply both sides by S0. Okay, to do what you did invokes a little bit of magical thinking. Okay, you're not moving S naught, although when you look at it, you say, yeah, I'd like to move S naught over here. Okay, and I think it goes here. You do it by the algebra 1 operations. You multiply both sides by S naught. Okay, because that's all you can do with an equation in this form. You multiply both sides by the same thing, divide both sides by the same thing as long as it's not 0, add the same thing, subtract, or take same power both sides. You got to be careful about extraneous roots, all that stuff. Okay, so what we have to do is, we want to get S here. We multiply both sides by S naught, because that's how we get our S naught over here. Okay. And really, this is S naught over 1 times S naught. And it could be rewritten as S naught over S naught times S and all that stuff. Not just cross them out. But if that gets the job done for right now, do it. This just gives you S. Here. Nothing wrong with this equation, but we usually put the variable that we solve for on the left, because that's the form we're used to seeing. Okay. Okay, so let's phrase this in terms of a question about an earthquake now. Now you got to be very careful that you understand every step here totally in context. Because you don't want to be making algebra 1 mistakes in the pre-calculus course. Okay, you want to definitely understand that once you have to solve this equation for S, your options are multiply both sides by the same thing, divide both sides by the same non-zero quantity, et cetera, add or subtract, and you got to know which one does this because you got to know the algebra fractions. Okay, but now, let's say we have a problem. Find S if M equals, and let's see what's reasonable. If M equals something wrong with this. First place, I've done worse than an algebra 1 mistake. This is M times 3/2, not 2/3. So I wrote that down carelessly, so don't do like I do. Do like I say. So hopefully you wrote it down right. Okay, hopefully not copying what I did. Okay, find S if M equals now S naught is 10 to the 16th. Now that's going to have units, but I'm not going to lay the physics of it on you. Okay, it's an intensity measurements, probably pressure per unit area. Okay, pascals per square meter or whatever. But we'll just accept that it's 10 to the 16th. Okay, because the units don't really matter. So what's S if M equals 3? Okay, so we want to find S if M equals 3, given that S naught is 10 to the 16th. Well, we've taken the equation, we've converted it into a form where we've solved for S. So we get, I'm going to write all our reasoning. M equals 2/3 log of S over S naught. So S equals 10 to the 3,000 M on S naught. If we could just quote this, you know, if we did that, I wanted to run through it in my head to make sure I've done it correctly. We want to be sure that we understand where this comes from, so we know what to do in a similar situation. Okay, so once we've solved this equation for S, we just plug in M. Okay. And that equals 10 to the 9/2 times 10 to the 16th. Okay. 10 to the 9/2 is 10 to the 4.5, which is square root of 10 times 10 to the 4th. And you could use your calculator to do that, but maybe think about understanding the numbers. So that's approximately 3.1 times 10 to the 4th times 10 to the 16th. And you'd probably bypass that with your calculator, but you're going to get 31. Well, no, actually, you're going to get 3.1 times 10 to the 20th. Okay. This is 31,000. Then you got to multiply that by 10 to the 16th. And you don't want to write out all those zeros, so use scientific notation, right? Okay, so you got to make sure you understand that. It's not necessarily how I got to 3.1 times 10 to the 4th. That's fairly easy. It's worth understanding. But your calculator will tell you the same thing. And now I find that my stupid camera has gone out of focus once more. Let me see if I can fix that. Just zooming out and zooming in. It looks like it fixed it. Okay. If I zoom in again. Once more, okay. Now it's out of focus again. It just doesn't like that distance. There it comes back. All right. Great camera, but that one flaw really kind of gets in the way. Okay, so there we have it. Well, that's basically how you use logarithmic scales and logarithmic equations and so forth. Okay. Now I could give you a problem. Find m if s equals 5 times 10 to the 21st. Okay. Well, that's easy. You just plug in and use your calculator to do the log, multiply it by 2/3, and you get m. So we're not going to do that. You don't have to do any solution of this equation in order to answer that question. Now, there are other questions, though, like okay. Got m equals 8.3 versus m equals 6.7. You want to know how much stronger that really is. I mean, 8.3 doesn't look all that much more than 6.7. Okay, maybe 10 or 20% more. Okay, maybe a little more than 20%, but it doesn't look like a big difference. Okay, but we're talking about the destructiveness of the earthquake, because that's what S tells you. S tells you how strong the earthquake is, how destructive. How much more damaging, how much worse would it be to be in this one than in this one? Well, it turns out that this is likely to kill you, and that's likely not to just cause a little property damage. Okay, I think I think in terms of the Richter scale, but it's a logarithmic scale, so it shouldn't make a lot of difference. So whether my intuition is right or not, let's figure it out. Okay, so what's S for this one? What's S for this one? Well, you're going to be able to answer that. So I'm not going to ask you to do it at this point. Okay, for 8.3, m is going to be 8.3. You're going to take 3/2 of 8.3. It'll be 12.45. And that's approximately equal to I'll just write in terms of S naught. Now you take your calculator and see how close to 3 times 10 to the 12th this is, but it's fairly close. And you don't really need to write out S naught. It's 10 to the 16th. So if you multiply it, you're going to get a 10 to the 28th over. And of course, make sure you understand scientific notation. Look it up if you need to. That's well, it's hard to read. There we go. Okay, well. If M equals 6.7, S equals, and I'm not going to fill in all the details, you're just going to plug in 6.7 for M, right? And treehouse of 6.7 is 10.05, I think. Okay. Okay. End of the 0.05. Brain isn't totally functioning today. Maybe that's 1.03, but don't quote me on it, I'll deny it. Okay. So we've got this, okay? Well, let's call this M1 and this M2. So now we're going to call this S2 and S1. Okay. If you want to know how much stronger, you're going to take the ratio of S2 to S1. It'll be this many times stronger. So if you divide S2 by S1, you find out how many times stronger. Okay. And we'll make a note of that. That's S0 times 3 times 10 to the 12 over S0 times 1.03. And don't believe that 1.03. I don't think it's accurate, but okay. It's this many times stronger. Now, of course, S0 divided by S0 is just 1. So we get just 3 times 10 to the 12 over 1.03 times 10 to the 10th. That's approximately, let's just pretend that 1.03 is right. If that's right, and it isn't, that'll be about 2.9, 1.03 into 3. And 10 to the 12th over 10 to the 10th. Well, I'll write that out explicitly. 10 to the 12th over 10 to the 10th. And that is 2.9 times 10 to the second. Now, again, you're going to need to maybe review scientific notation if you haven't used it that much, and how you divide powers, subtract the powers that you're dividing and all that stuff. Laws of exponency, rules for exponents. You've got to be real straight on those things, or you're going to be prone to costly errors. Okay, well, that's $290. 10 to the second is 100, 2.9 times 100, 290. So this is 290 times stronger. The worst looking M I've ever written. It's 290 times stronger than M equals 6.7. to be a whole lot worse to be here. It's not 20% or 30% worse. It's 290 times as bad. And that's inherent in the way logarithmic scales work. Now, we're not going to have time to talk about the intuitive idea of logarithmic scales. You're probably going to have to read that, review notes, lectures, whatever. Okay, because we've got like 15 minutes left. But this is the mechanics that you would use to solve these things. Okay, so okay, you asked about decay rates. I'm just going to say decay, and actually I'm going to say this is in the context of growth and decay. Y equals AB to the T. That's a general exponential function. This thing, Y grows. With increasing T. If B is greater than 0, not greater than 1. Okay. And it decays if B is 0, if B is less than 1. It means every time T increases, you're going to multiply your Y. T increases by 1, you're going to multiply Y by B. So every time you multiply by B that's greater than 1, your number gets bigger. So if you multiply by like 1.5, and then multiply by 1.5 again, you've multiplied by 2.25. If you multiply by 0.9, and then multiply by 0.9 again, you get 0.81. Now there's a lot of examples I typically go through with this, but time's not going to permit us to get through them all. So we're just going to kind of accept that, but make sure you think about it and understand why it's so. Okay, now. If R is your growth rate, and R greater than 1 causes actual growth, it's like R is your percent. If your growth rate is 10%, then R would be 0.1. Okay, 10% means 0.1. If your decay rate is 10%, then R would be negative 0.1. So I'm going to say that R and R greater than 1, I can't keep 0 away from 1. R greater than 0 causes growth. R less than 0 causes decay. And B in this model is 1 plus R. So for example, growth rate 10% means R equals 0.1. So B equals 1 plus R, which is 1.1. The decay rate is 10%. Means R equals negative 0.1. So B is 1 plus R, which is 1 plus negative 0.1, which is 0.9. Okay. So R equals 0.1 tells you that Y equals A times 1.1 to the T. That's growth. And if R is negative 0.1 or negative 10%, then you get A equals 0.9 to the T. Now, higher and higher powers of 1.1 get bigger and bigger. Higher powers of 0.9 get smaller and smaller. Well, now let's go to the arithmetic of this thing, of the algebra. Looking at the clock, and I can't really run over because I've got another class coming. I would be glad to. State it like this. If R is 0.8, how long does it take for Y to fall to half? Okay, so, well, in model is Y equals A times 0.8 to the T, where A could be any number, it could be your initial amount of stuff. Okay, Y is the amount of, A is the initial amount of stuff you have, Y is the amount you have after time T. Okay. Hopefully you've digested some of that. Okay. So A is your initial amount. What value of T makes Y equal to 1/2 A? So I want you to think about that and see if you can come up with a reasonable answer there. Okay, well, when you want Y equals 1/2 A, so you're going to want 1/2 A to equal A times 0.8 raised to the T. Now, can you solve that equation for T? Okay, first thing you do to solve this, divide through by A. If you divide both sides by A, then you don't have A there anymore. Now, you need to do that carefully. You need to understand why you divide by A. If you divide 1/2 A by A, you get 1/2. You divide this by A, you get 1. And we get 1 times 1/8. Then change form. You get E equals log base 0.8 of 1/2. Now that equals, and you got to remember this, hopefully you have this down, but that's just, it's easy enough. It's the log of 1/2 divided by the log of 0.8. And in this case, it turns out that this is approximately 3. The amount falls to half the original in time 3. If it's in days, T's in days, then it takes 3 days for this amount to fall to half. It's a radioactive element or the chemical in your bloodstream or one thing or another that has an exponential decay. It's going to fall to half in 3 days. Then in another 3 days, that will fall to half. So you're down to 1/4 of what you started with, and so forth. And the mechanics of solving the equation are just the same as always. You just have to know your rules for logs and how to convert from exponential between exponential and logarithmic form. Wish we had time to do a little more with it, and wish the camera would stay in focus, but that's probably too much to hope for. But there it is in focus. Okay.